Let us consider a problem. Here we are given a sequence xn in a space X, and it is given that it has a cluster point small x in the space. If the space is first countable at that point, then there exists a subsequence which converges to the point small x. For the proof, let us assume that the space X is first countable at the point small x, and let us consider family L, which is equal to V1, V2, V3, etc. the countable local base at the point small x. We are given that the sequence xn has a cluster point at small x. Now let us construct another family, say L dash, as follows. Suppose L dash is equal to the collection W1, W2, W3, etc., where W1 is equal to V1, W2 is equal to V1 intersection V2, and W3 is defined as V1 intersection V2 intersection V3, and so on. Then, if we consider any neighborhood, say N of the point small x, then as L is a local base at small x, there will exist some Vm element of L such that N contains Vm. From the construction of the family L dash, there will exist Wm from L dash such that Wm is a subset of Vm and Vm is contained in N. As we have defined Wm as the intersection of the sets V1, V2, etc., Vm. This ensures that the family L dash is also a local base, a countable local base at the point small x. Since the point x is a cluster point of the sequence xn, we have for every positive integer n, and there exists Wn element of L dash and some term, say xrn, from the sequence such that xrn element of Wn using the property of cluster point of a sequence, then we will be getting a subsequence xr1, xr2, xr3, and so on. Then for any open set, say G containing our point small x, there will exist some Wm element of L dash such that Wn is contained in G using the property of local base. Also, for every n greater than or equal to this index m, Wn will be contained in Wm from the construction of these sets. It is obvious, and hence xrn will belong to Wn, and Wn is contained in Wm, and we know that Wm is contained in our G. Therefore, for any open set G containing X, there exists an index M such that for every n greater than or equal to M, xrn belongs to G. This implies that sequence xrn converges to point small x. Thus, we have proved that every sequence in the space X has a convergent subsequence which converges to the point small x.